I think I've just decided to track other bits of information in the ets table. It's the easiest way to broadcast it, and then when you disconnect, you can just delete it. Because otherwise, you have to create a private channel, and then you create an enormous surge from whenever somebody joins that everybody else has to send messages down to through the server into that person's channel and get back onto the front-end client when you could just send it from server to client if you just cached it, and it's not that much data to cache. I also noticed that when after join we insert into the ets table, but we're never deleting. So even after you if the space channel is garbage collected, the entry into the ets table is not. So I think we should check if there's a termination. So implementation true. And is it terminate? Terminate reason argument. And just no reply socket, I guess. So if no reason, and well, I can just maybe IO inspect reason label is the reason, and IO inspect arg1 label arg1. I want to see what that is, and yeah, just variable socket does not exist. Okay, because okay, terminate needs what? It doesn't matter. Invoke when the channel process is about to exit. So if I simply close the browser, that should cause a shutdown. Closed. Okay, we don't really care what the reason is. In this case, it was oh, this is the socket. Arg1 is the socket. And the reason I think is shut down, and we just want to delete this. And so in case you have this, remove yourself here. So we're going to look for etsref socket assign slug. If there isn't, then we can push server lost Otherwise, it's ref. And we'll do ets delete 1 or delete 2. Deletes the entire table. So we don't want to delete the entire table. We want to delete object. Delete the exact object from S table, leaving objects with the same key, but other differences. Useful for bag. What kind is this? It's a set. Alright, so we want to delete table xref, and the key is socket assigns number ID. And then after this happens, I think I should just do the print out what this thing is. ets.tab to list with a table. Let's put that to IO inspect. So Chrome. If I just close this, boop, I think this is it. There's nothing in the list. Otherwise, let's create 2. So let's do Chrome and Firefox. So if I close 1, I get this thing, 1 remaining. And if I close this, no remaining. Good. Okay. And then as soon as you pop back in, yeah, you should create your entry again. Alright, so that handles a key of just the member ID, which holds the member position, and maybe we should push in another key for state. But how did we, let me look at the presence again, presence. Here, we're getting all of, okay, so we're getting the entire table, all presences related to this. And do we want all states as well? Should we hold state in there as well? I remember there's a reason why I formatted it like this. Is because you can actually pattern match on the values in here, right? Let's take a look at the ets table features. Insert public, protected private, self the ETS has no schema. The only limitation is that data must be stored as a tuple whose first element is the key. Okay, so this is the table and the first element is the key. Is that how we insert? Space channel insert. Yeah, insert first. That's not how we did it. This is a tuple with the first element as a key, but we inserted. Oh, no. Insert and the first argument is the table. And the. Well, this is a. What? The second element of this is a 2. Am I just doing this wrong? When we use insert with a set or order set, existing data will be replaced. To avoid this, there's insert new, which returns false. Data must be stored as a tuple whose first element is the key. But here insert says tab when tab object reference is a tuple or a list of tuple. Okay, the second argument that I provided is a tuple. inserts the objects or all of the objects in a list. So maybe this is a newer version of Elixir that supports a different syntax. If the table type is set and the key of inserted objects matches the key of any object in the table, the old object is replaced. Yes. So in this example, this is the table, and this is a tuple with the first element of the tuple being the key. Oh, I'm looking at this wrong. Okay, here's insert. This is the table, and this is a tuple. The first element is a key. I'm just tired. Data retrieval. It offers a few convenient and flexible ways to retrieve or store data. We'll look at how to retrieve data by key and through different forms of pattern matching. Most efficient and ideal retrieval method is key lookup. While useful, matching iterates through the table and should be used sparingly, especially for very large data sets. While the most efficient and ideal retrieval method is key lookup, while useful, matching iterates through the table. So it's O of n key lookup. Given a key, we can use lookup to retrieve all records with that key. It says it's the most efficient and ideal is key lookup. And then it says while useful, matching iterates through the table. Given a key, we can use lookup to retrieve all the records with a key. So here's the table and the lookup by the key. I'll just bring it back. Okay. Simple matches. ETS was built for Erlang, so be warned that match variables may feel a little clunky. To specify a variable in our match, we use atoms, $1, 2, and 3, and so on. The variable number reflects the result position and not the match position. For values we're not interested in, we use the underscore variable. Values can also be used in matching, but only variables will be returned as part of our result. Let's put it all together and see how it works. So it's match. Okay, here it says lookup is most of it, and then matching is this. So here's the table. Oh, okay. So position where you don't know, for example, my thing is a member ID, and then you want this, and then you don't care about this. Will still match the $sign, bringing this back. Let's look at another example, is that $99, $1 and 3, what? Result position, not the match position. What does this mean? This just matches everybody, right? Not clear what this does. What if we want original object, not a list? Match object. Okay. This means you don't care what this is in 1 and 3. Match object. Anything that matches Sean here. I don't understand this $sign thing. Oh, is $sign the thing that you give back? Match object gives back the whole thing. This thing gives back an array of the first thing goes here. Okay, so that's the result. The second thing, or the third thing, was the tuple part. And finally, that becomes the last thing. So that I switched over here. Okay, you switch the order, I see. And then advanced lookup. We learned about simple match cases, but what if we want something more like an SQL query? Thankfully, there is a more robust syntax available to us to look up our data with select. We need to construct a list of tuples with arity 3. These tuples represent our pattern, 0 or more guards, and a return value format. Our match variables and two new variables, $, and $_ can be used to construct the return value. These new variables are shortcuts for the result format. Take a look at one of our previous match 2 examples and turn it into a select 2. Okay, this gives back the match object, and you can do select, which is constructing the return object, and then $. Well, that's a crazy syntax. I don't quite understand here. So you're getting arrays of tuple with the first thing being a tuple, and then I don't know what this is. Although select2 allows for finite control over what and how we retrieve records, the syntax is quite unfriendly and will only become more so. To handle this, its module includes fun2ms, which turns functions into match specs. We can create queries with familiar function syntax. Let's use and specify all user names with more than 2 languages. Okay, so function to ms find username languages when length of languages is greater than 2. Okay, you can use some guard statements there. So theoretically, you could use this to find users with a position over a certain length. Actually, we could have the front end, the server detect when, like, how many unmuted users, and then send down an join and then unjoin. Could do that server side. Though it's a little tricky, and it's not really a server concern, is it? Deleting data. So this is maybe more on fun2ms. That's cool. So we could use this to store blink, 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 blink using the fun2ms. fun2ms. Any more information about this fun2ms? No, oh, wow, it takes a function and it produces a match spec. Crazy syntax. Oh, so that's saying when I get a tuple that matches this thing, and it's okay, it's saying it's abstract syntax tree. So when x first argument is greater than 10, this condition is met, then supply the whole object, I think. And then ets test this thing. It's like, okay, 42, 43, and what is this? V2? What? Oh, V2 means execute that in there, which gives you, okay, that means it passed. And this one, because the first argument is 0 instead of being greater than 10, it failed. Fun2. It's fun2ms. Match spec. So you write a match spec, and then you give it to select, or the reason ets works like this is because it's basically a macro. To use this in Erlang, you need to include it. Include line in Erlang instance that does run the parse if transfer is not done at compile time, but runtime, and it gives that rather clumsy error message. This include also the build method there. Parse transfer like macros and stereo. So you pass it to select the table and ms. Okay, so you put it back and then insert here counter. Okay, so this is a list of tuple. tab to list. Named bag, insert. Oh, but it's a list of tuples, or you can insert a list of tuples. So in each case, I think this is the key. In fact, we can test this. So we can go like this. Did that, QC, and then he did this, and then he did tab to list. But if you do, let's say if you delete QC and then counter as the key, and then look at it again, counter, both pieces of counter were deleted, so they are individual, and then you could build this match spec that says given the key and the, I guess, the times, when key not equal to counter, when key is not equal to counter, and then give me back the t. Okay. Or give me back the key. Okay, so let's copy this. I'm going to modify this a bit. So I want match spec, give me key and this when t is greater than 3, and give me back a tuple with k and t. Alright, and then do select with QC and MS, and I get bar. That is cool. So I think I would be able to use that to leverage position, and I wouldn't care about rotation necessarily, but then I would just put underscore underscore under those other places, right? So could I do that? Just give me like that. Maybe. Sure. Position rotation, so that's something that I might want to search by. So let's just create a new key. So we've created a new table. Yeah, it's not a new key, a new table. So in our space server, we have ets.ref. So we're gonna have more than one ets.ref now. Okay, let's just sleep on this. Okay, any create new ets.ref table for space server so we can store member state about Mike, nickname, avatar, etc. So that when a new user joins the space, we can tell them all about the existing members in the space. This doesn't need to actually be in the memory though. Or when a new user joins, they can query about existing members once. Nobody said we had to hold it in memory. You can create a table for member info, although it's, so if you're not updating it all the time, for example, member movement, rotation, and hands, how often are you saying that somebody's muted or not muted? Not very often, right? You just delete that record if they leave. You don't have to hold it in memory. Just hold it in database table, a few milliseconds to save that, and then somebody joins, and they can just say make one additional query. We don't actually have to fetch this from, it's complicated, right? When a new user joins, ask for the previous state of all members. Probably you can do that. Straightforward. Doesn't have to use fancy ets technology. It's probably good enough. Okay, let's take a break.